Everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm making my last video in the first topic, basics idea of statistics. So remember on the first three videos I talked about basic concept of statistics, sampling, types of data, design of experiment. Today we are going to consider the bias of study. So what is the bias of study? Usually, no study is perfect. Even a very well conducted study might generally not give the result that is exactly correct. So the bias is basically a tool to measure how good a study is. So first of all, we are going to define bias. Let's look at this example. Imagine that you were to draw a simple random sample of students at a certain college to estimate the percentage P of students who are Democrats. So what we are going to do is we are going to collect the samples. Here I'm going to collect n samples. The first sample, sample 1, I'm going to determine the sample percentage of students who are Democrats. For example, if I sample 200 students and 150 students of them are Democrats, then P1 hat is 75%. And similarly for sample 2 and sample n, after I collect n estimates P1 hat, P2 hat to Pn hat, what I'm going to do next is I'm going to take the average of these n estimates. So let's say P hat is the average of P1 hat, P2 hat to Pn hat. So if P hat is exactly P, P here is the population percentage of students who are Democrats. So in this case, I'm going to say P hat is an unbiased estimator of P, and a studies that give an unbiased estimator for the parameter is said to be an unbiased study. So a study conducted by a procedure that produces the correct results on the average is said to be unbiased. So opposite to unbiased is biased study. Let's look at this example. Imagine that you try to estimate the percentage of Democrats in the population by selecting students who attended a speech made by a demographic politician. So in this case, on the average, studies conducted in this way would overestimate the percentage of Democrats. That means the estimate is generally higher than the true population percentage, because people who attended the speech made by the democratic politician usually mainly agree with Democrats. So this study conducted with the methods that tend to overestimate or underestimate a population value are said to be biased. So overestimate means the estimate is higher than the true value, and underestimate means the estimate is lower than the true value. So if in average the estimate is not the same as the true value, then this is said to be a bias study. So definition: bias is basically the degree to which a procedure systematically overestimates or underestimates a population value or a parameter. So a study conducted by a procedure that tends to overestimate or underestimate a population value is said to be biased, and a study conducted by a procedure that produces the correct result on the average is said to be unbiased. Here I want to stress one word here, on average, because if you to take only one sample, usually one sample cannot give the exact estimate, the estimate that is exactly equal to the true value. It's almost it's impossible. So here we need to collect a large number of samples. Then we take the average. So if the average is the same as the true population value, then that is an unbiased study, otherwise it's a biased study. So now we are going to define different sources of bias. So sources of bias. Let's look at the first type bias, voluntary free response bias. Remember on sampling methods we learned about one sampling method called voluntary free response. So voluntary response bias is basically the bias that is connected to voluntary free response sample. So usually it happens in voluntary free response sampling method, and the reason is in many cases the opinions of people who choose to participate in the surveys do not reflect those of the population as a whole, and in particular people with strong opinions are more likely to participate. Remember, in voluntary free response, usually people with negative opinions tend to participate into voluntary free response sampling. So in this case, usually voluntary free response samplings are highly biased. So this is the first bias. So the second type bias is self-interest bias. So many advertisements contain data that claim to show that the products being advertised is superior to its competitors. Of course, the advertiser will not report any data that tend to show that the product is inferior. So this bias is basically applied for companies, industries, because usually companies don't want to have negative reports about their products. So even more seriously, many people are concerned about a trend for companies to pay scientists to conduct studies involving their products. And in particular, physicians are sometimes paid by drug companies to test their drugs and to publish test results of the tests in medical journals. People who have an interest in the outcome of an experiment have an incentive to use bias methods. So that's the second type of bias. And this type bias usually happens in companies and manufacturers. So that's the second type. Now we move on to social acceptability bias. So people are reluctant to admit to behavior that may reflect negatively on them. This characteristics of human nature affects many surveys. For example, in political polls, it is important for the pollster to determine whether the person being interviewed is likely to vote. So a good way to determine whether someone is likely to vote in the next election is to find out whether they voted in the last election. It might seem reasonable to ask the following question: did you vote in the last presidential election? The problem with this direct approach is that people are reluctant to answer no because they are concerned that not voting is socially less acceptable than voting. So usually we try to ask the question by indirect way. Like we, instead of asking like, are you going to vote in the upcoming presidential election, we are going to ask, did you vote in the last presidential election? Because if we ask them, are you going to vote, and if they say no, the behavior of not voting is a little bit negative. So usually people will avoid to say no. That's why like we try to manipulate a question to make the people more comfortable to answer honestly. So we change the question to, did you vote in the last presidential election, instead of asking, are you going to vote? Next, Leading question bias. Sometimes questions are worded in a way that suggests a particular response. For example, a particular group that supports lower taxes sent out a survey that included the following question: do you favor decreasing the heavy tax burden on middle-class families? So the words heavy and burden suggest that taxes are too high and encourage a yes response. So this is not a good way to ask because people tend to answer yes. So a better way to ask this question is presented into a multiple choice question with level agreement. So where is your here's a better question. What's your opinion on decreasing taxes on for middle class families? We have 5 choices: strongly disagree, somewhat disagree, neither agree nor disagree, somewhat agree, or strongly agree. So here we have more reliable answers from people who taken the surveys. Next, no response bias. So remember, when we talk about free response sample, sometimes some people are free to choose whether they respond or not. So that's why we also have a bias study, because many people will not respond to the survey. So here people cannot be forced to answer a question or to participate into a study. In any study, a certain proportion of people who are asked to participate refuse to do so. These people are called non-responders. So in many cases, the opinions of non-responders tend to differ from the opinions of those who do respond, because usually people with strong opinions or negative opinions tend to respond more usual than people who have positive or light opinions. As a result, surveys with many non-responders are often biased. Next, this is the last bias in the sources of bias: semblance bias. So semblance bias occurs when some members of the population are more likely to be included in the symbol more than others. Remember, in convenient symbols, sometimes it's almost impossible to collect a simple random symbol, so people tend to collect symbols of convenience. And remember, when we learn about symbol of convenience, symbols of convenience are sometimes not acceptable. So that is a sort of bias. Symbols of convenience almost always have semblance bias, because people who are easy to symbol are more likely to be included. It is almost impossible to avoid semblance bias completely, but modern survey organizations work hard to keep it at a minimum. So usually we cannot make a semblance method perfect. We should try to minimize the bias, minimize the mistake. So that was about bias and sources of bias. Now we are going to discuss about one small point. A big sample size doesn't make up for bias. Usually we tend to misunderstand that if we make the sample large, then the estimator will become unbiased. But actually, even if we make a very large sample, if we collect a very large sample, but the sample is not if the sample is not random, then the study cannot be unbiased. So a sample is useful only if it's drawn by a method that's likely to present the population well. And usually the best way is simple random sample. If you use a biased method to draw a symbol, then drawing a big symbol doesn't help. A big non-representative symbol does not describe a population any better than a small non-representative symbols. for example, if you want to consider a female drink, and you take a symbol of more male students than female student, then that symbol cannot be the best representative for the whole population. In particular, voluntary free response surveys often draw several 100,000 people to participate. Although the symbol is large, it is unlikely to represent the population well, so the results are meaningless. So that was about bias of study. Now we are going to practice on some problem. Problem number 1. 80,000 people attending a professional football game filled out surveys asking their opinions on using tax money to upgrade the football stadium. 70% said that they supported the use of tax money. Then opposed the survey a simple random sample of 500 voters, and only 30% of the voters in this sample supported the use of tax money. The owner of the football team claims that the survey done at the football stadium is more reliable because the sample size was much larger. It is right, explain. So here we have two investigators. The first investigator surveyed 80,000 people from the professional football game, and 70% of them supported the use of tax monies. But then another poster used a simple random sample withdrawn from 500 voters, not at the stadium. 30% of the voters in the sample supported the use of tax money. So the problem with the first investigator, even though he claimed that he's right because he used a larger sample size, but the problem is larger sample size doesn't make up for bias. Remember that the point of a larger sample size doesn't make up for bias. So the answer is he's not right because the sample taken is unbiased. The football fans are more likely to be sample, and this is sampling bias, and also an example of big sample doesn't make up for bias. So the first investigator was not right because he, first of all, even though he used a large sample size, but the sampling method was not acceptable because he collected only people from the football stadium. This is kind of a convenient sample. Problem number 2, a polling organization played telephone calls to 1,000 people in a certain city to ask them whether they favor a tax increase to build a new school. 200 people answered the phone, and 150 of them opposed the tax. Can you conclude that a majority of people in the city oppose the tax, or is it likely that this result is due to bias? So you see here we make the phone calls to 1,000 people, but only 200 people respond, and 150 of them oppose the tax. So you see that usually people with negative opinions will tend to respond to the phone call, and here only 200 people responded. So that means this is a high degree of non-responser, right? So this is no, there is a high degree of non-response bias. Problem number 3, a bank sent out questionnaires to a simple random sample of 500 customers asking whether they would like the bank to extend its hours. 80% of those returning the questionnaire said they would like the bank to extend its hours. Of the 500 questionnaire, 20 was returned. So this is the sort of free response, non-response bias. Problem number 4, an e-store that sells cell phone accessory reports that 98% of its customers are satisfied with the speed of delivery. So here, in this case, this is a self-interest bias because usually when we collect opinions about a product of a company, but the reports were made by the company, so this is self-interest bias. So remember, this is different from free response bias because the reports were made from the company. So usually the company tend to make a positive report for their products. So that's why this is a self-interest bias. You see, an e-store reports that 98% of its customers are satisfied. So this is self-interest bias. The last problem, a television newscaster invites viewers to email their opinions about whether the U.S. Congress is doing a good job in handling the economy. More than 10,000 people sent in an opinion. So this is a voluntary free response bias. This is a voluntary free response symbol. So that is everything of today. Now before I finish the lesson today, I would like to recapture the whole picture of statistics and introduce the next lesson. So statistics is basically a study of collecting data, summarizing data, and making a conclusion. So in statistics, we have 3 steps to process. The first step is collecting the data. The second step is descriptive statistics. And the last step is inferential statistics. So on the first step is basically just sampling and experimental design, which is covered in chapter 1. So we have learned, up to now we have finished the first step. Then for step 2, descriptive statistics, this is what we are going to work on the symbol. So remember, after we collect the symbol, after we collect the data, we have to summarize the symbol, and then we use the symbol to make inferences to the population. So step 2 is basically summarize the data, and we have 2 types summaries. Graphical summaries, we are going to use some stat graphs like box plot, histogram, steam leaf plots, bar charts, pie charts, and many types of graphs. And we also have numerical summaries, the phi number summaries, like mean, median, mode, standard deviation. So the second step is basically work with the symbol, and the last step is working with the population. Like we use the symbol, we use the summaries we got from the symbol to make inferences for the population. So in inferential statistics, we have point estimator, confidence interval, hypothesis testing, and linear regression. So next lesson, we are going to talk about graphical summaries, which is chapter 2, lesson 2, and numerical summary is lesson 3. Then we are going to do some preparation before we go into step 3, inferential statistics. So inferential statistics, we have point estimator will be captured in chapter 7. Confidence interval, hypothesis testing will be in chapter 8, 9, and 10. And linear regression will be in chapter 11. So that is everything for today. Thank you so much for watching my video, and I hope you guys still following up with me, and hope to see you guys next time. Bye.